Hey guys, how's it going? This is the third video of the series of videos I'm doing on AWS. In this video, I would like to cover the network ACL part of things with a simple example. All right. We have seen how to create a VPC, what is internet gateways, the NAT gateways, the route tables, the security groups, and all in my previous videos. If you have not looked into those videos, I recommend you to go through them. One of the things that I talked about in my previous video is like the security groups, which acts like a firewall, right? So where does the security group sits? It's like in front of a machine, right? You can have multiple security groups, up to 5 security groups attached to a single machine, or one security group if you want, right? And they're at the machine level. And one of the significant things about security groups is that they are allow only. There is no way to write the deny stuff there, right? So that's the whole point of things why we get into network ACL. Now think about this case, right? Let's say you have to deploy 100 web servers in your environment, and one way to do it is, yes, you can write one security group or associate all of that machines to them. But then think of this: security groups is allow only rules. What if you have to do denies, right? And then now think of 50 deployments of dissimilar servers that you have to do. And if you think about even controlling things only at allow level, writing 50 different security groups for 50 different machines is going to be a pain, right? So can I do something at the subnet level instead, right? Can I tier my setup in such a way so that a particular subnet hosts only a particular set of applications, and if in that particular layer the security of what comes out and what comes in and what goes out are specifically filtered out, and that's what network ACL serves for. So let me explain about the setup I currently have. It's a very simple setup. I have a running instance in one of my own VPCs, and I've done the usual stuff of having an elastic IP attached to that, and then I have an internet gateway through which my machine is loggable. If you guys are not familiar on how to do it, please look into my previous videos. You'll get to know about things, right? And then let me get on to the security group of this machine. Let's go to EC2, and I'll just have the security groups that this machine is attached to shown up, right? Now let me, this is the security group on which I have just made this machine available. So this machine is, as you see, it's an SSHable and a pingable security group, right? So I've opened out all SSH, all ICMP here. So that's the thing about the setup I have. Now this is the machine that's there. Now let me exit and let me start. If I want to do a ping on this machine, let's see if that responds. Right, now let's assume the case of network ACL, right? And let's do the things practically. I just want to allow SSH and ICMP to a subnet instead of doing it at the security group level. Can I do it at an ACL level? So two things to be very specific about network ACLs is that network ACLs, as I said, it overcomes the disadvantage of a security groups by writing both allow and deny rules. But on the serious side of things, what happens with the network ACL is that it's a stateless thing. So let's say you have your inbound traffic that comes through SSH, and then let's say if the response to that SSH handshake comes on a different port, which is usually not the case, but then just taking an example, right? If the response to SSH port comes through a different port, To allow this, you have to specifically write a rule to allow this handshake happening successfully. So that means you have to write both inbound and an outbound rule, right? So let's get into the practical side of things. The first part of things is, let me go to my network ACL straight away. I'll get into the VPC and just see that the ping response. Let me start an indefinite ping here, right? Let it keep on pinging, and the network ACL, right? I'll try to create a new network ACL for this. Let's say my network ACL is test NACL01. Let's say that, and putting it onto my VPC. It's an optional layer of security that acts like a firewall, as it says right from the definitions here. As soon as I do this, now let's look into the inbound rules. It says all traffic deny inbound, all traffic deny outbound, and subnet associations. And I'll just go ahead and put the subnet associated. As soon as I do this, let's look into what happens. Right now, I have associated this subnet to this NACL. As you see, all inbound is deny, all outbound is also deny. Now let me go here, and I see a request timeout. That's what exactly happens. So now the behavior that you see here is that this is at a subnet level, even though the security group allows you to SSH and ping to this machine, but at a security level of NACL, we have denied it, and that's why the ping response has gone now. Now let me try to write a simple inbound rule, okay, where I'll say that I'll just go here, add another rule, and here is the number 48, right? Let's why 48 because I like the number 48, right? So that's the whole point of it. And but there is a little thing to that. Let me give that to you in a minute. So here is what I'm writing. I'm saying that please allow pings from anywhere in the outside world, an IPv4 ping. And what does this rule number tell? So usually when you have a list of rules that you can write in the security group, each of them should have a number, right? And in this case, the numbers takes the precedence in which the order of the rules get evaluated. Let's say I have number 48 and then 49. 48 gets evaluated first, and then it goes to 49. We'll come to that in a short while. And we should also remember that when there is a rule that is matching first, right? The evaluation of rules for allowing a particular traffic ends there. Let's say that I write a rule saying 48 allow all SSH from public, and then 49 deny SSH from say for example a particular subnet, let's say 10.x.x.x of my own premise network, right? The second rule doesn't matter because the first rule matches the criteria to allow SSH to actually be allowed from anywhere outside. So it doesn't necessarily evaluate the rule number 2. That means you have to be a little careful in writing the order of the rules. If you want to deny traffic from a particular subnet, write that first and then allow the public stuff, right? And then there is a star rule that I will talk about as soon as I save this now, right? And I have a star rule, which means that's the rule that gets evaluated at the last. All traffic, deny them. So that's the rule that's there. So now, having written this rule, let's go and look into things. Still not pinging, right? So I've written only the inbound rules, the response. So there is a request and a response. So the inbound thing is the request that's going to the machine. Now how about the outbound thing? Let's go there and write an outbound rule. Edit, add another rule. Let's say the same rule. This is an outbound rule, 48 all ICMPv4 respond to this one, hello, save, right? As soon as I do this, what happens? Starts pinging. The machine starts pinging without anything, right? So that is the significance of network ACL. Here you have a facility to define what goes in, what goes out of the machine, and it overrules the security group that you have. The simple thing is that there are cases where you need to control at a machine level. There are other cases where you can tier the control at a subnet level, and if that is the case for you, then network ACLs work. And what is the fine level control that network ACL gives you is an inbound rule and an outbound rule. So you can control literally everything, every traffic that comes into a machine on every port, on saying allow this, don't allow that, and kind of a thing, right? So that's the whole thing. Now let me, having executed the ping NACL rule successfully, let me try to write an SSH rule now, right, to make things more clear once again. So here in this case, what I'll do is I'll just go ahead, put an inbound rule saying, add another rule, 49, let's say, I'll say SSH, I'll just save this. Now can I try doing this SSH to this machine? Probably won't work, right? So think of this case, right? I mean, in your data center, if you want to monitor some machines and based on a ping response, and you don't want people from unknown subnets just logging into the machine, you can write this rule saying that, okay, I'll just allow pings, don't allow SSH to this subnet, right? So that's the kind of things that you can do with the NACLs. But now what is happening here is I've written just an inbound rule. Now the request has gone through to that machine, but then the response is not coming, right? So let me go ahead and try to write an outbound rule now, where I say edit and another rule, let's say 49. I'll just write a simple rule saying all TCP. Okay, let's see that gets executed well. This is kind of not a more secure rule that I'm writing, but just for the demo purpose I'm just writing this. So as soon as I write that, let me try to do this, and the machine SSHs. That's the whole point of it. Now you have an inbound rule that requests for SSH, and then an outbound rule that responds to it, right? So now let me again, sorry, I'll exit this out and I'll edit this rule again, and I'll say SSH again instead of ICMP. Save. Now what does that happen? Let's say how does things work here? As you see, the SSH is not working out well here, because the thing is that we don't know the request to our SSH session. What is the response that comes back, right? On which port does it comes back? So that's the whole point of it. So now this is all about SSH thing, right? Now that's the whole point of network ACLs. So network ACLs help you to give a more granular control, which says, okay, allow this inbound, allow this outbound, don't allow this inbound, don't allow this outbound. If you want to do a complex example, let's say you try to execute this in your setup, right, that you have, try to create a VPC in which there are essentially two subnets. It might be at two different availability zones if you want, right? That doesn't matter. Now let's say you want to execute a rule saying that from subnet 1 all machines in subnet 2 must be SSHable, right? But the reverse rule, from subnet 2 any machine on subnet 1 should not be SSHable. Try writing this rule, right, and you'll come to know about the nuances of network ACL. I'll try to cover that as a part of one of the demo videos that I have, the same use case that I've told you about, right? So, but in general, now we know that what is a network ACL, and I hope that explains things clearly. Thank you very much. Meet you in the next video.